Okay, in this question we've got a curve C with the equation x cubed plus 2xy minus x minus y cubed minus 20 equals 0. And we're going to find dy dx in terms of x and y, and then we're going to find an equation for the tangent to the curve at this point. Okay, so first of all, let's find dy dx of this. So I will start off, we'll go dy dx of x cubed plus 2xy minus x minus y cubed minus 20. So we start off like that. Now, to take derivative of this with respect to x, we've got a few little problems here because we've got x and y terms mixed. So what we're going to do is do implicit differentiation. That's what we're doing here today. So now what we're going to do is apply dy dx to each of these terms. I'm going to show you how to do each part as we go along. So dy dx of x cubed. So derivative of x cubed, I'm just going to write it down like this. Derivative x cubed dx plus, then I'm going to write the derivative of 2xy. Now 2xy, we've got two different variables mixed, so I can't really go straight away into that. So what I'm going to do now, I'm going to first of all do derivative of 2x, so d 2x dy, but then there's a y there, so I need to multiply it by the y. Okay, and I haven't taken derivative of y yet, so now what I'm going to do is I'm going to add the 2x, do the derivative of y with respect to x. That way then I'm taking care of both sides. So that's that taken care of. Now the minus x, so minus dx dx, y cubed, so minus derivative of y cubed dx, and then minus 20, so derivative of 20 dx. Okay, that's our setup. So now we're going to go through each one and explain to you each one as we go along. So derivative of x cubed with respect to x, that's straightforward, that's just 3x squared. So that is fine. Right, derivative, sorry, this has got to be an x there, sorry, that's my mistake, that's an x. So the derivative of 2x with respect to x, that's just 2. But we've also got to multiply it by y, so that's 2y. Okay. Next we've got 2x multiplied by the derivative of y dy dx. So what we do here is we add 2x and leave the dy dx in. So that becomes like that. Okay. Then the derivative of x with respect to x is just 1, so that's just a minus 1. Now this one's a little bit more confusing. So derivative of y cubed and then the dy dx, or dy cubed dx. So how we do this is we take the derivative of y cubed. So derivative of y cubed is 3y squared, and we leave the dy dx in there. And so we take care of that, and then the d20 dx, that's 0. Derivative of 20 is 0. Constant multiple, that's all 0. So now we stick the minus 0, the equals 0 back in, and then what we do is now we're going to move all these terms around and try and isolate the dy dx. So we've got a 2x and a 3y squared with the dy dx. So what we're going to do is it's 2x, that's a positive, but it's a minus 3y squared. Okay, and then it's all dy dx. And then we're going to move everything else on the other side. So let's start from the 3x squared. So move that on the other side, we've got minus 3x squared, 2y, minus 2y. This is done. Minus 1 comes across, that becomes a plus 1. And this one's taken care of. And then the 0, we don't need to have the 0. Okay, So now what we do is, if we divide by this to get dy dx on its own, so we divide that by that and divide that by that. So we can imagine dividing everything by 2x minus 3y squared, and this side divided by 2x minus 3y squared. And then this will just cancel out, and then we're left with dy dx equals minus 3x squared minus 2y plus 1 over 2x minus 3y squared. So that is our answer for dy dx. Okay, so that's part A taken care of. Next bit, I'm going to find the tangent to the curve C at point 3, minus 2. So that's at x equals 3 and y equals minus 2. So first of all, let's plug in our values for x and y for here to see what dy dx equals. So dy dx at 3 minus 2 equals minus 3 times 3 squared. That's the 3 taken care of in there. Minus 2 times y, which is minus 2, plus 1. And then we're going to divide that by 2 times the x, which is 3, minus 3 times minus 2 squared. Okay, so now we got minus 3 times 3 squared is minus 27. Minus 2 times minus 2 is plus 4, and then plus 1. Divide that by 2 3s is 6. Minus 2 squared is 4. Times that by 3 is 12, so minus 12. So that gives us minus 27 plus 4 plus 1 is minus 22 over minus 6. So that equals 11 over 3. So this now gives us our gradient. So dy dx is nothing more than the gradient. So we could say, using gradient term m equals 11 over 3. So now using the formula for the equation at this point, we go y minus y1 equals m times x minus x1. And that will give us an equation for working out the gradient, the equation for the gradient. So let's plug our values in. So we can call that y1 and x1. So y minus minus 2 equals m, which is 11 over 3, times x minus x1. So x minus x1 is 3. Okay. So this will become y plus 2. And then multiply both sides by 3. We get rid of this 3 on the denominator. And then gives us x minus 3 times 11. Okay, now let's just move that around a little bit. So 3y plus 6 equals 11x minus 33. Okay, now let's get all these all on the same side. So now we've got 11x, 3y becomes minus 3y, and then we've got minus 33 minus 6, that becomes minus 39. Okay, so then that's our equation to C at this point, and that's our answer.